Everybody, in this video, we are going to solve the following example that you were asked to try to solve on your own. And that was this equation 1 minus 3 tan 2x equals negative 7 tan 2x minus 4. Now, we are asked to solve this equation on the interval 0 to 2 pi. That means your answer needs to be in radians. That means if a calculator is ever involved in these equations, that your mode would have to be in radians if you needed to use a calculator to get the angle measure. If the calculator was in degree mode, it would give you degree answers and it wouldn't apply. It doesn't say solve for the exact answer or approximate. So if it said exact, that would indicate we don't need a calculator. If it said approximate, that would indicate we probably need a calculator, or we do, because we're going to approximate. So that's interesting. And we just want to make sure that something like negative 3 tan 2x or negative 7 tan 2x, these are glued together with multiplication between the 3 and the tan, or the 7, and or really negative 3, I'm sorry, and negative 7 and the tangent. It is tangent of 2x, not times 2x. It is within the tangent. You can't just separate them all willy-nilly. And then this is attached, like multiplication is attached to the tan, but the 1 is being added to the negative 3 tan 2x, or you could say 3 tan 2x is being subtracted from 1, whatever. So we're going to work with that to get started. You can't combine the 1 and the 3. You can't combine the 2x and the 4. They're not part of the same type of expressions. They're not like terms. We can't combine them. So what I'm going to do is I'm going to bring this negative 7 tan 2x to the right with addition. So I'm going to add 7 tan 2x to both sides. And while that will cancel out right over there, we don't need the parentheses. I will combine over here, the coefficients combine, but I will simultaneously, I'm going to bring this 1 to the other side. So I'm going to subtract 1 from both sides. Okay, I know it's a little bright, maybe lower that a smidge. There we go. So negative 3 plus 7 gives us positive 4 tan 2x equals negative 4 minus 1 gives us negative 5. Next thing that we're going to do, if you brought it the other way, you would have had a positive 5 here and a negative 4 tan 2x here. All good. If you had a negative 4 in front, a lot of people try to add 4 in the next step. You have to divide, okay? Again, the 4 is attached with multiplication. We're going to divide both sides by 4. That reduces, it's gone. And we have tan 2x is negative 5 over 4. Now, since we're on a unit where we're dealing with the double angle identities, a lot of people are going to be like, must use double angle identity. Tan 2x equals 2 tan x over 1 minus tan squared x. If you do that, and like, I guess sort of do a little diagonal multiplication, multiply the bottoms over, right? You get a quadratic, you're going to have tan squared, you're going to put it into standard form-ish, get it equal to 0. You're going to try factoring, it's not going to work. You're going to have to do the quadratic formula. Instead of x equals negative b plus or minus the square root, b squared minus 4ac all over 2a, you're going to have to do tan of x equals, or actually tan of 2x equals negative b plus or minus. Then you're going to get 2 different answers. Then you're going to have to use the calculator anyway. What a nightmare. So why would we do that? Let's not do that. We can just solve this using basic trig inverse like we did right at the beginning of learning trig inverses. How quickly we forget, right? So I'm going to take the tan inverse of both sides. Tan inverse of tan 2x and tan inverse of, you don't multiply by tan inverse, don't be that person, negative 5 over 4. Took tan inverse, so I'm left with just 2x equals, now remember, when you take the tangent inverse yourself, you need to include all the answers up front, and then we're going to narrow it down to our window after. So while that will go in the calculator, tan inverse 5 over 4, it's really saying to you, or negative, I'm sorry, the tan of what angle is negative 5 over 4. If that was like root 3 over 1 or root 3 over 3 or 1 or 0, You could do it in your head, or negative of any of those, but it's not. So we need a calculator, but we apply first a general solution. So we need to include plus pi n, where n is an element in the set of integers. Why is this going to come in really handy? Because we're dealing with the 2x. When you have a 2, think of your graph of tangent. When you have a 2 on any trig graph, and tangent normally looks something like this. If we just do one cycle, typically we find ourselves drawing 2 cycles. So we could see a bit more of it. That's 2 cycles of tangent of just tan x. That would be from 0 to 2 pi. But if we put a 2 in there, that was a horizontal compression. So now this, well, now we're going to have a compressed version. So that gets me to pi. And then now I'm at 2 pi. So I have a lot more graph being squeezed in between 0 and 2 pi. And I want to know, when does it equal -5/4? Well, if this red line is my sinusoidal axis, pretend that's, oh, sorry, that's not straight at all. Pretend that's the x-axis, okay? Then in, let's grab another color, green, -5/4 is somewhere below it. How many times does my green line intersect with my blue tangent graph? Well, 1, 2, 3, 4. These are dashed lines. I know they're a little sloppy, but 4. So I'm going to get 4 answers. And the way we get those answers is by implementing our general solution. If it was over here, we would just have 2 answers if we did not have that 2x, okay? So now we continue. And why pi? Because the period of tangent and cotangent's pi. The other 4 is 2 pi. So that's what we would add on over there. So let's continue, shall we? Also, in addition to putting that in the calculator, I'm going to divide everything by 2. That, and that. So then we just get x equals, okay? So I'm going to go over here just because, you know, it gets a little messy. And I'm going to need my calculator that I hope I have handy. Okay, have the calculator. So I want to put in the calculator the tangent inverse in radians of -5/4. Every calculator is different. Just be careful and, you know, follow along carefully. But I have a little R on my screen that is radians. Sometimes it'll say rad if it's a D or a DG, degrees. You might have to go into like mode or something to change it. On this one, mode? No. Shift setup? Yeah. Degrees would be press 3 and 4 would be radians. So, you know, it's just, I was already radians, but just explore your calculator, trial and error, figure it out. So I need tan inverse. So for mine, I double click tan, I think. Oh no, that was the other calculator. Just kidding. Shift and tan. There's my tangent inverse. And negative, sometimes the negative is its own button. On this calculator, it is the minus sign, which I actually find weird. And if I hit enter, I'm going to get a decimal. Bam. I'm going to divide by 2. Bam. And that is sort of like my starting number. I'm going to round, hence, you know, we're being approximate, nowhere does it say the exact. So -0.448, but I'm going to leave this full number on my calculator screen. Do not hit clear. I know some of you are very clear, happy people. So -0.448. X equals, well, it's approximately equal to -0.448. 4, 8 plus pi over 2 n. We already established that n is an element instead of integers. We want answers between 0 and 2 pi. That's negative. That certainly is not between 0 and 2 pi. In fact, that would have been the answer if this is the y-axis where 0 is. That is the answer probably if I go whoop right there. There it is, you know? So I need to add that increment of pi over 2 once, twice, 3, and 4. 4 times to get my answer. So let's get to it. I got that on my screen. And I'm going to do plus, let's do parentheses to be safe. And I want pi over 2. So do I have a pi button? Probably. Why am I blind to the pi button right now? Oh, there it is. Okay. So shift pi over 2, close, enter. That should be your first answer. So x is approximately equal to 1 point. You're going to go out as far as you really wish. I'm going to go 1, 2, 3. Okay. Then comma. Now, I think if I just hit enter again, it's going to do the answer, which is that now, plus that. And I could just keep hitting enter. Just be careful when you like square things or whatever. It gets to be very messy. 2 point and round correctly. 6, 9, 4. Comma. Remember, we got to be less than 2 pi, which is approximately 6.28. So when we deal with decimals, you know, you got to be careful with that. Again, enter. 4.264, comma, 5.835. And those are my 4 answers right over there. We got them. So I wrote them all down. Solve between 0 and 2 pi. We're done. If you did it trying to use the double angle identity, good try, but think smarter, not harder. I hope this was helpful. If this made sense to you, thumbs up. Does not make sense to you, put a thumbs down so we at least know what kind of things we need more examples of. All right? Have a great day.